Hello class, today we are going to go over Unit 6 lesson number 4, which is 6.4 transformations of trig functions. So everything in terms of the equation letters like A, K, D, and C will be the same here. So today we're going to learn how to graph equations of these two highlighted forms using transformation statements, so mapping notation, and using characteristics. Okay, so just keep in mind, you can have theta in here as your equation. Sometimes it might be x or another letter. In this case here, remember the 5 key points on our sine graph. Get used to writing theta now in terms of radians. Okay, so it's going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Remember, that's just another way of saying 0, 90, 180, 270, and 360. And we know sine starts at the center of its graph at the equation of the axis. So it starts at 0, goes to its max of 1, back to the equation of the axis, back to its min, and then back to its equation of the axis. Okay, so it always starts at EOA, okay, then max, back to EOA, min, and EOA. That is, of course, because sine theta has a positive a value. Okay, so assuming positive 1. I have here written at the side CI equals pi over 2. So CI we're going to go over a bit more as well. It's the critical interval. So basically it's the distance between the 5 key points on a sine graph. So that means if I start at 0, I move pi over 2 to the right and I hit my next key point. I move another pi over 2 to the right and I reach my next one, and so forth. Over here for cos, so remember cos has those same theta values here. It also has a critical interval of pi over 2. Okay. What's unique about cos is that the cos graph, so when the a is positive 1, starts at its max, then goes to its EOA, then goes to its min, back to the EOA, and ends up at its max again. Okay, so you always have to remember those shapes, because when we graph using characteristics, we're going to have to remember those key points and how they work in that order. Okay, so when we transform those key points, remember A refers to vertical stretches or compressions. Okay. And we say by a factor of the absolute value of A. And it can deal with reflections across the x-axis. So that is if A is negative. All right, our next one is K. K deals with horizontal stretches or compressions by a factor of 1 over the absolute value of K, and or reflections across the y-axis. And we know D is our horizontal translations, and C is our vertical, same as always. So remember, if I ask you to transform using coordinate transformations, that means I expect you to use our mapping statement, which says xy on the original becomes x over k plus d, comma, ay plus c. All right, it says the following transformations are applied to the graph of y equals sine x, where x is between 0 and 2 pi. Okay, so see how x can be used just like a theta. Right here it's telling you that it is in radians. All right, we've got a vertical stretch by a factor of 3, a horizontal compression by a factor of 1/2, a horizontal translation pi over 6 to the left, and a vertical translation 1 down. So let's come up with our letters. From this point here, we get that A is 3. A horizontal compression by a factor of 1 over 2 tells us that in the equation, K was actually just 2. Horizontal translation pi over 6 to the left means that D was negative pi over 6. And vertical translation down means that C was negative 1. So that means our transformed equation is going to be g of x equals 3 sine, and then you're going to have to do a square bracket, your k value, circle bracket, x plus, right, because it's originally as a negative, so a negative and a negative makes a positive, pi plus pi over 6, close the bracket twice, and -1 on the outside. And that's your transformed equation. Okay, let's turn over. Now we are going to sketch this graph by applying transformations. So again, this is a hint that you have to use your mapping statement. All right, so let's leave the graphing for now. Let's just come up with those tools first. So our mapping statement based on our equation, okay, here it is again at the side. We have a at 3, k at 2, d negative pi over 6, c negative 1. So in our mapping statement, that's going to look like this. Okay, so that's going to be x over 2 minus pi over 6 equals, sorry, got cut off there. Write it out. Okay, so equals 3y. Okay. And then our c value was -1. So that is our mapping statement here. Okay. So x over k plus d, d was negative, and then ay plus c, c was also negative. All right, so we always start with y equals sine x, the parent function. So we should write out that table of values. We know the x's go from 0 to 2 pi, and our y values 0, 1, 0, -1, 0. Now we're going to set up our table of values for the transformed function using what we have up here. So our transformed x coordinate, x over 2 minus pi over 6 in one column and 3y minus 1 in the other. So this one's going to involve a lot of work because we might have to find common denominators because we're doing this without using a calculator. So our first one, we're subbing in 0 and 0. So here that's going to be 0 over 2 minus pi over 6. So that cancels out and we're left with negative pi over 6. 3 times 0 minus 1 means that we're just going to be left with -1. All right, now we have to plug in pi over 2 in for x. Okay, so we're going to get a fraction over a fraction here. All right, so we're going to get, so I've drawn in a different color here, pi over 2 divided by 2 minus pi over 6. Okay, so that's what I plugged into here. All right, what does that equal? Pi over 2 divided by 2 is actually pi over 4, because you're going to end up multiplying these two. So we get pi over 4 minus pi over 6. We can't combine these unless we have a common denominator. We want to find a common denominator of 12, so I multiply the top and bottom of this fraction by 3 and top and bottom of this fraction by 2. That leaves us with 3 pi minus 2 pi all over 12, which leaves us with 1 pi over 12. When I sub in the 1 for y, I'm going to get 3 times 1 minus 1, and that leaves us with 2. All right, next point. Now we have pi and 0, so now I'm plugging in pi here. So here we have pi over 2 minus pi over 6. Again, I can't simplify without a common denominator of 6. This one's already good, so I'm going to multiply top and bottom of this guy by 3. So that leaves me with 3 pi minus pi over 6. So that's 2 pi over 6, and in lowest terms, that is pi over 3. And then 3 times 0 minus 1 will give us a value of -1 again. Okay, next point, now we're going to sub in 3 pi over 2. So we're doing 3 pi over 2 divided by 2 minus pi over 6. So again, those two 2's will be multiplied. So we're going to get 3 pi over 4 minus pi over 6. We're in the same issue. We have to find a lowest common denominator of 12. Multiply these top and bottom by 3, these top and bottom by 2. So we're going to get, here we're going to get 9 pi minus 2 pi. That's going to leave us with 7 pi over 12. For y, we're subbing in -1. So we're doing 3 times -1 minus 1, which will leave us with -4. And lastly, our next point to sub in is x value of 2 pi. So 2 pi divided by 2 minus pi over 6. So here, again, you want the common denominator. Even though you could cancel this to pi, you know you're going to have to find a common denominator anyway. So we're going to get 6 pi minus pi, okay, all over 6. That leaves us with 5 pi over 6, and we're subbing in 0, so we're ending up with -1. So here we have our end values here. Okay, let's highlight them. Okay, so these are our x coordinates of our 5 new transformed points. Okay, and of course these are our y coordinates. These ones are easier to see here. All right, so we have to plot these 5 points now. So the tricky part with something like this is looking at how we are going to graph this on the x-axis, meaning what interval should we go by? So what should be our critical interval, or how much should I make my scale, should depend on things like the d value and the critical interval. So notice here, we want to make graphing as easy as possible for us. So I notice that I've got intervals of pi over 6. I reach pi over 3. Pi over 3 is a multiple of pi over 6, right? Because pi over 6 represents 30, that represents 60. So then I have to ask myself, how am I going to easily graph x values of pi over 12? So, because here we've got another multiple of pi over 12 here. So I think to myself at the side here, I know pi over 12 is 1/2 of pi over 6. So that means, notice here that I decided to do my scale in terms of the d value pi over 6. Okay, even d is negative pi over 6, but in terms of intervals, I'm just saying the positive version here. So here I decide, so I have one at the negative here, so each tick is going to represent pi over 6. So that means this one over here is negative pi over 6, which means this first tick is pi over 6, and then I want you to start counting. So this one here is 2 pi over 6. In purple, I'm going to write what its lowest terms is. So in lowest terms, 2 pi over 6 is pi over 3. Then I have 3 pi over 6. I know that reduces to pi over 2. Then we have 4 pi over 6. That reduces to 2 pi over 3. 5 pi over 6. 6 pi over 6 reduces to pi. 7 pi over 6. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6. 3 pi over 2 in lowest terms. 10 pi over 6 is 5 pi over 3. 11 pi over 6 can't be reduced. And 12 pi over 6, 2 pi. All right, once you've done this, okay, so that's the most difficult part. I also look at my y-axis. I need to be able to reach a max of 2 and a minimum of -4. So I just did every 2 ticks, I went up by 1 on the y-axis, and then you might go off a little bit with the -4 here. So I'm going to extend my graph a little bit, just so it's a bit more spaced out. So we can go off a little bit to -4. All right, so you're probably wondering, well, how are we going to graph things like pi over 12 and 7 pi over 12? So that's what I have here in red. So if I know one grid square is pi over 6, then that means I know half of a grid square is pi over 12, because pi over 12 is 1/2 of pi over 6. So in red, I'm going to count by pi over 12s. 1 pi over 12, 2 pi over 12, which reduces to pi over 6, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12. This guy here is going to be the 7th pi over 12 interval. This is important because I need to know where 7 pi over 12 is to plot this point. So that means this point is going to be at 7 pi over 12 negative 4. Okay, so 7 pi over 12 and negative 4 is going to land about right here. All right, so go ahead now that we've plotted that, and I want you to plot every single point we have here. And when you do that, you should get a graph that looks like this. So notice I've graphed it in red. Okay, so I've drawn our one cycle, right? So I know my first point here started at negative pi over 6. I went up to my max, back down to my equation of axis, down to my min, and back up to my equation of axis, right? The common shape for sine when a is positive. Notice here that I've just continued it, so I've drawn the graph for 2 cycles. So because we don't have those key points with us, the quick way of doing this is to kind of notice how many grid squares you travel until you get to the next key point. So for example, from this key point to this key point, right, I traveled 1.5 grid squares. So that means to get to my next key point, I should travel another 1.5 grid squares. So if you finish here, you should go 1.5 grid squares over and get your next key point. Then you should go another 1.5 grid squares over, reach your next key point at the equation of axis, and then you keep going with that pattern. I've also drawn in the parent function sine here so that you can see how it's been transformed. Okay, let's try the next question. So that's how we draw it using transformations. The other way will be to transform using characteristics. So that means we take the a, k, d, and c value and we come up with all the key features we need to draw it. So absolute value of a will give us the amplitude of the function. Okay. If the sine of a is also important, so there's 2 things with amplitude, what the absolute value is, and then the sine of a. So this indicates if the cycle is reflected across the x-axis or not. So you need to know for sine, if a is positive, then your cycle is going to start at the equation of the axis and then go to its max, okay, what we're used to. However, if you have sine and the a is negative, then that means it's been reflected. So you're going to start at the equation of the axis still, but then you're going to go to your minimum, so it's going to be reversed. So it'll look like this: equation of axis, minimum, equation of axis, max, equation of axis. Okay. So still all those key points, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. For cos, if a is positive, then you know the cycle you're drawing will start at the max, and then it goes to its equation of axis. Okay, so it'll look like this. Okay, so its key points will be 1, 2, 3, 4, and 5. If the a value is negative, then the cycle will start at the minimum and then go to the EOA. So it's going to be the flipped U shape. Okay. So it'll start at 1, 2, 3, 4, and then back to its minimum. Okay, so that's very important to know. You'll get the k value from the equation, and when you do 2 pi over the absolute value of k, keep in mind most of the k values will be positive in this unit, typically. This will give you the period of the function, so you know when to start and stop. Okay, same idea. This comes from the fact that absolute value of k is 2 pi divided by the period. So when you rearrange that, it gives you the same thing. The d value gives us the horizontal translation. So when you're starting from scratch, what's important about this is that it gives you the x value of the start of the cycle. Okay, so you know where you're starting. What's also important is you want to find out, if you know where you start, you want to know where you should stop. So the x coordinate of the end of the cycle should be the d value, right? That's the start, plus the period, because you know it's going to end after that length of time. Y equals c gives us the equation of the axis. Okay. So right here, if that's my sine graph, for example, y equals c will be cutting it in half. What's good about knowing this in the amplitude is that I can find my max and min values, because I know my max is going to be up here. So that's going to be found by doing c plus the amplitude, right? And that'll give me this. If I want to find my min value, that's going to be c minus the amplitude. So that means I'm coming down here and finding what that y value is. And notice amplitude here is always absolute value, because it's amplitude is saying what is the distance between max and min cut in half. Okay, so distance is always positive. And lastly, the critical interval, very important. Okay, so it's the x interval that it takes to reach the next key point. All right, so this comes from, here's the drawing here. If you have 5 key points, so 1, 2, 3, 4, 5, how many intervals does that create? That creates 1, 2, 3, 4 spaces contained between them. So we're not going on the outside, so just spaces in between. So that's why the critical interval is the period, right? So this part here, the period divided by 4, because you want to cut it up into 4 chunks. All right, so let's try some practice here. It says the following function has the parent function y equals sine x. Its graph has a period of 10 pi, amplitude of 2 over 5, equation of the axis 1 over 15, and a horizontal translation of pi over 3 to the right. Determine the equation. All right, so our k value depends on our period. So we know that k equals 2 pi divided by the period. Okay. So that means we get 2 pi divided by 10 pi, and that equals 1 over 5 when reduced. Because the pi's will cancel out here, and then 2 over 10 reduces to 1 over 5. All right, our a value, we've been told here that it has an amplitude of 2 over 5, so that told us that absolute value of a is 2 over 5. Okay. Remember, amplitude doesn't tell you whether it's positive or negative. So because in the description there was no mention of a reflection across the x-axis, we are going to assume then that a is positive, so that means a is 2 over 5. The d value we get from the horizontal translation. Since we went to the right, it's going to be positive, so just pi over 3. And our c value is going to come from our equation of the axis. So c equals the equation of axis, which is 1 over 15. So that means our equation is g of x equals 2 over 5 sine square bracket 1 over 5 as our k value, bracket, x minus pi over 3, close bracket, bracket, and then plus 1 over 15. And that's our transformed function that meets those requirements. Remember, moving forward, just like we've done in previous units, that we have to always factor the argument. Okay, so the argument is the expression in which the function operates. So basically I want you to think of it as like the input. Okay, so in this case here, so this would be the argument of sine. So sine of what? Sine of the argument. So I notice here it's not in proper transform function notation. So that means I have to factor out my k value here, and my letter here is t, so I have to factor out 2 pi. So that's going to leave me with 10 sine square bracket 2 pi bracket t plus, and then if you do 1.5 pi divided by 2 pi, the pi's cancel out. 1.5 divided by 2 leaves us with the 3 over 4. Close the bracket, plus 15. So make sure you do that, or else you will have the incorrect d value. Okay, so let's practice again here. Let me just fix that here to the d value. Okay. All right, so we have y equals 3 cos 2x plus pi. So again, I see a coefficient other than 1 with the x, so I divide out 2, and that will leave me with 3 cos bracket 2 and then x plus pi over 2. Okay. So in this case, my a value is 3, my k value is 2, my d value is negative pi over 2, and my c value doesn't exist, so it's 0. All right, let's try on the next page. All right, it says, given this equation, we have to state the transformations that were applied to the parent function cos x, and then we're going to sketch the graph using its characteristics. So the first thing we're going to do here is we're going to factor k out. So k, as you can see, the coefficient in front of x is 1/2, so we're going to divide that out. Okay, so we have negative 2 cos, and then we took out the 1/2. So that's going to cancel it out here, so we're left with x, which is what we wanted, and then minus pi. Okay, so because pi over 2 divided by 1 over 2 leaves you just with pi, and then plus 3. Okay, right? 1/2 divided by 1/2, anything divided by itself is 1, and then you just have pi. All right, let's describe the transformations using proper terminology. So our negative value here tells us that we have a reflection in the x-axis. The amplitude, right, so absolute value of A is 2, so that means we have a vertical stretch by a factor of 2. We have a k value of 1 over 2, so that means we have a horizontal stretch by a factor of 2. D is pi, so horizontal translation pi right. And our c value is 3, so a vertical translation 3 units up. All right, and like I said, now we are going to sketch the graph by using amplitude, period, translation, and axis. All right, so let's scroll to the bottom here and where we can do our work. So let's start with the amplitude. So there's 2 things we need to get from the a value here. Okay. So the first thing we're going to analyze is that the amplitude is the absolute value of negative 2, so the amplitude is 2. Okay. So we know that that's going to be important for helping us find our max and min. Okay. However, we also need to analyze the a value to determine how our cycle is going to be oriented. So I notice that I analyzed the sine of a. Because a is negative, so a is less than 0, and we're dealing with cos, that tells us then that the cycle will start at a minimum point. Okay, so when we draw it, it's going to be like this. Okay. So it's going to start here at a minimum. All right, now we're going to move on to the equation of the axis. So we figured that out because we know it's whatever it's y equals whatever the c value is. So we get y equals 3. And you're going to notice I kind of started drawing that in there if you've already started your graph. All right, because we have amplitude and equation of axis, we can find the max and min values. Again, you can do these characteristics in kind of whatever order you want, but these 2 can't be done until these 2 are found. So we know our max value is going to be the equation of the axis plus the amplitude. So in other words, that's the C value, so the middle ground, plus the distance to the top. So that is 3, right? 3 plus amplitude of 2, so that gives us a max value of 5. So now I know how far up I'm going to go, so that means I know this point here is going to be 5 in terms of the y-coordinate. Now we're going to find our min the same way, but we're going to subtract the amplitude. So equation of axis minus amplitude, so C minus absolute value of A. So that's 3 minus 2, which leaves us with a minimum value of 1. So I've kind of keeping it all highlighted here because I know that that's what this value is going to be over here. Okay. So we basically just found out that this point up here is going to be 5. And the y-coordinate down here is going to be 1. All right, the period of the function. So that's going to be 2 pi divided by k. All right, and that leaves us with 2 pi divided by 1/2. Remember, flip and multiply, so you get 2 pi times 2 over 1. So that's a period of 4 pi. All right, our horizontal translation, that will be our d value. So our d value was pi in the equation. So what does this tell us? This gives us the x-coordinate of the start of a cycle. So basically what they just told me is I knew the y-coordinate of this, but I didn't know the x-coordinate. So the x-coordinate they just gave me is pi. So I know my first point is going to be pi and 1. Because I know this, I can also, now that I know the period and the start, I can add those two together to get what the end of the cycle is. So that's going to be d plus the period. So pi plus 4 pi, which means I'm going to end at 5 pi. I know I'm going to end at 5 pi over here. And lastly, in order to graph the rest of this in good symmetrical form, I need to know how often a key point occurs. So that's the critical interval. So that's the period divided by 4. So that's going to be 4 pi divided by 4, so pi. So that means every pi units from here, right, so that means I'm going to move pi over, and then I'm going to reach my next key point. I'm going to move another pi over, and I'm going to reach my next key point. Pi over, key point, and then pi over, and I end up where I want to be. Okay, so those distances are all going to be pi. All right, so we know that it's going to start at pi and end at 5 pi, so I was able to space out the x-axis here a little better. So I did every 2 ticks, I went up by pi. I also just went up by 1s on the y-axis. And now we're going to start drawing. So the first thing you're going to want to do is you're going to want to draw in your equation of the axis. So at y equals 3, your horizontal line. That's important because you need to know that that's where you hit your next key point. Okay. All right, so let's start our graph. We know we're starting at the minimum at pi and 1. Our next key point is going to be, right, our critical interval is now pi. So I'm going to jump another pi. And then I know cos goes from, when it's reflected, it goes from minimum to the equation of the axis. So my next key point is going to be 2 pi and 3. Then I know I'm going to jump another pi units, and now I should be at the max. And I know that max value is 5. I'm going to jump another pi units, and I'm going to be at the equation of the axis again, right? Because we're doing an upside down shape here now. So I know I'm back at 3. And then I'm going to shift another pi, and I should be back at my starting position, which is at the minimum of 1. And that is how you draw a cycle using characteristics. So you can see how every piece of information here we needed to know in order to set up our graph properly. and make sure you label. Okay, so label your equation of axis, label your graph here, and then you can just put arrows there. So remember, you have to know that the minute you realize this, that you can draw a little rough sketch for yourself at the side. Okay. Or else some students will do this wrong and then start at the max, forgetting that the graph had been reflected. All right, let's try a few more. So remember, follow all the same process. If I gave you a graph, and then I ask you to find the equation. So now we're going vice versa, okay? So the first thing that you want to do, so for example in this question here, determine the equation of the function below in terms of sine and cosine. So I need to find the equations for this graph. And by the way, there is an unlimited amount of equations that you can use. All right, so part 1 says that you want to first locate the equation of the axis and enter that in as the c value. Okay. All right, so let's do this here. Now notice we have to do sine and cos. So our first job is that we want to highlight a sine cycle. But if you notice here, it's hard to highlight sine without knowing where to start at the equation of the axis. Okay, so it's important that we do that first. So we find the equation of the axis, that's the halfway point between the max and min. So y is going to be max plus min divided by 2. You should remember this from last year. That's 7 plus negative 3 divided by 2. So 4 divided by 2, so we get 2. So that tells us in our equation that the c value is 2. So I'm going to draw that in. And notice that's important because maybe your eyes thought the middle or halfway point was something else. So it's always good just to verify there. I have had in the past where students might start sine, for example, starting up here because visually they thought that was the halfway point. So doing the math will be helpful. All right, now the key thing is we do want to highlight a cycle of sine. All right, so our first cycle of sine, I always try to find the nearest cycle to the origin that starts at the equation of the axis. So for example, I'm noticing 1 starts here. Okay, looks like it comes up here, comes back down, and sine should, its cycle should end when you come back to the OA. So this is the equation, or this is the cycle that I'm going to find the equation for. You may also identify another sine cycle. So someone may have identified a sine cycle starting from here, then going up and back down and said it was reflected. So that's okay too. That's why some answers may vary for this unit. Okay. All right, so we've got our c value. Now we want to find our amplitude. So you're going to locate the max and min points and use them to find the amplitude. So we know amplitude is equal to max minus min divided by 2. Okay, so that's 7 minus negative 3 divided by 2. 2 negatives make a positive, so we get 10 divided by 2. So we get an amplitude of 5. Now remember, we only know that that's the absolute value. Now we need to analyze what kind of cycle we highlighted. So my sine cycle that I highlighted goes to the max right after the EOA. So see how I start here and go to max. So that tells me that for my cycle, my A value is going to be positive. So that means I can make the conclusion that the A value of my cycle will be positive 5. If you highlighted one that goes from EOA to min, then your A value will be negative 5. All right, the period. A quick way to find the period is by identifying the x-coordinate of the end of the cycle and the x-coordinate of the start of the cycle. So if you notice that here, okay, we need to find this, that's the x of the start, and we need to find this, that's the x of the end. So what's tricky here is we have to figure out what are these increments here. So what does each square represent on the x-axis? So we know that 3 squares represents pi. So that means 1 square must be pi divided by 3. Right? 3 squares made up pi, so 1 square is pi over 3. So knowing that, that means the x-coordinate of the start of the cycle is negative pi over 3, because it's just 1 unit to the left. Right? This is pi over 3. This is 2 pi over 3, 3 pi over 3, 4 pi over 3, which means based on counting, this is 5 pi over 3. So if I come down here, I'm going to use that now. Okay. So 5 pi over 3 minus, and then the x-coordinate of the start is negative pi over 3. Okay. 2 negatives make a positive, so I get 6 pi divided by 3, so I get a period of 2 pi. Okay. All right, now that we know the period, remember what we need to find is an equation, so that means we need to know the k value. So we know k is 2 pi divided by the period. We know the period is 2 pi, so 2 pi divided by 2 pi, so we get a k value of 1. All right, and lastly, we need our horizontal translation. So our d value is the x-coordinate of the start of the cycle, and for me that is negative pi over 3. Okay, so look at that. We have a, k, d, and c up here. So that means our sine equation with all that together is g of x equals 5 sine x plus pi over 3 plus 2. Now, when we are working with, so we just worked with a transformed sine function. Okay, so we looked at the x value that gave the point where the function intersects the equation of the axis, right? So we found this value here that was d. Okay, I'm going to put that here. It's our d value. Okay, for sine. So d for sine. Now we have to find the equation in terms of cosine. So that's going to be a little different. The first thing that I want you to do is I want you to highlight, so get a different color, and you're going to highlight a cosine cycle that you see. So I usually try to pick ones that do have a positive a value, just for simplicity's sake. So I'm going to start with my cosine cycle that starts up here, kind of halfway in between there. Okay, and I don't want to overlap the other one. But my cosine cycle that I want to find the equation of is going to come all the way back up to here. Okay. So that will be cosine. I'm going to find the equation of this. So if we've already done this work, you should notice that for cosine and sine, the equation of the axis should always be the same. Okay, so I know it's going to be the same as here, so it's going to be 2. Now the a value is where things could change. The value can't change, but the sign can. So the amplitude is going to be the same, so 5. However, depending on what cycle of cos that you've highlighted, the a could be positive or negative. So because I highlighted a cos cycle that started at its max, therefore I'm assuming a is positive, so in this case they also have the same a value of positive 5. The period of the function for sine and cos, that is always the same. The one thing that will for sure be different is the d value. So for a transform cos function, you want to look at the x value that gives the maximum point, again maximum if you're assuming it hasn't been reflected, to determine the d value. So let's find that here. So this is the d value right here for cos. So we have to figure out what that is. Okay, so this I'm going to write as d of cos. So if 1 square is pi over 3, then we have to do pi over 3 divided by 2 to see what half a square is. Pi over 3 divided by 2 is pi over 6. So that means cos starts at d equals pi over 6. The start of the cycle. So that means the cosine equation is going to be, and you're going to see very similar to this one, just different d value, 5 cos x minus pi over 6 plus 2. All right, and last question here. It says a mass on a string is pulled toward the floor and released, causing it to move up and down. Its height in centimeters above the floor after t seconds is given by the function, which is nicely factored and everything, where time is between 0 and 3 seconds. Sketch a graph of height versus time, and then use your graph to predict when the mass will be 18 centimeters above the floor as it travels in the upward direction. All right, so same old stuff. We're going to start by finding the amplitude. So we're going to graph this using characteristics. All right, so our amplitude is the absolute value of A, so that's going to be 10, so 10 centimeters in this case. Our A value is positive, so it means that our sine cycle will go to the max after the min, or sorry, after the EOA. Okay, so it's going to start right there. Okay, so it's going to have this green shape here, start at the EOA, max, EOA, min, EOA. All right, the equation of our axis is going to be the C value of the equation, so 15 centimeters. Y equals 15. Our max and min, so our max is going to be C plus the amplitude, so that's 15 plus 10, so 25 centimeters. And our minimum is going to be C minus the amplitude, 15 minus 10, so 5 centimeters. Our period is going to be 2 pi divided by k, so that's 2 pi divided by 2 pi, so a period of 1 second, right, because time was in seconds. Remember, period deals with the x-axis, which is time. The y, max and mins and things like that deal with the y coordinates, which represent height. All right, our horizontal translation. We have a d value of negative 0.75. So I know that the x coordinate represents, or the t coordinate here represents time. Just for the sake of drawing, we're going to start our cycle at negative 0.75, even though we know, right, that doesn't really make sense in real life. It'll help us with the drawing of the graph. Now we want to find the x coordinate of the end of a cycle, so that's d plus the period. So that means we will end our first cycle at 0.25 seconds. And lastly, we have our critical interval, which is period divided by 4. So that's 1 divided by 4, which means we have a critical interval of 0.25 seconds. So that's why I've kind of come over here and I've drawn, okay, I'm going to go 0.25 seconds over and I'm going to hit my max. 0.25 seconds over EOA, and then I keep doing that. All right, so let's start our sketch. Okay. When we draw, so again, we should be starting at negative 0.75. Right, was where we were starting. And then we were going 0.25 over. We were going to hit our max. So just look at the red line for now. I've already drawn in my green equation of axis. All right, from here, we're going to go another 0.25 over, and we're going to hit our EOA. We're going to go another 0.25 over, we're going to hit our min, another 0.25 over, and we're going to hit our EOA. So as you can see here, this is the one cycle we've just drawn based on the equation. I wrote this part in kind of dotted lines because we know it doesn't really make sense in terms of negative time. So now I just want you to follow that same pattern. I want you to keep moving 0.25 over and then going to the next key point. Okay? 0.25 over, back to the max of 25. 0.25 over, back to EOA. 0.25 over, down to the min. 0.25 over, back to the EOA. You're going to keep doing this until you reach 3 seconds because we have to analyze for that interval of 0 to 3 seconds. All right, so right now you should have the green line and the red graph, which is h of t. The whole point of doing this was because we don't know how to algebraically solve this yet, we have to graphically solve it. So we have to determine when the mass is 18 centimeters above the floor as it travels in the upward direction. So notice I drew in a yellow horizontal line, okay, do the best you can, of where y equals 18 would be. Okay. Now obviously we can see y equals 18 crosses the graph at 1, 2, 3, 4, 5, 6 places. But they said the upward direction only, so that means I'm doing for all the stretches of arms where it's increasing. So that would be this point here that I've circled in purple. Okay, so that's about 0.3 seconds. The next upward direction at 18 is here, which is about 1.3 seconds. And the next one is here, and that's at about 2.3 seconds. And that would meet the 0 to 3 interval. So my therefore statement is it reaches 18 centimeters in the upward direction after approximately 0.3 seconds, 1.3 seconds, and 2.3 seconds. All right, hopefully everyone enjoyed this. Usually students remember this a bit better from last year. Make sure that you are able to draw graphs using transformations and characteristics, and let me know if you have any questions with the homework. All right, see you for the last lesson.